All right, so in this problem number 12.2, it's all about the frequency distribution, a statistical graphic. We are going to study in this section what is the frequency distribution. So you will have to go through some definition again, upper class, lower class, what is a class, what are the rules for data groups grouped by class, which is number one, the class should be the same width. Second one, the class should not overlap. And number three, each pieces of data should belong to only one class. You will have also to deal with histogram and polygraph and frequency of Polygon. So we are going to start to do the problem number one. In this problem number one, it's about finding the definitions, a listing. So let me write the definition and then we'll get back to it. So, a listing of observed values and the corresponding frequency of occurrence of each value is called a frequency of frequency distribution. Problem number 4. So the class of a frequency distribution with a first class of 10 to 19 and a second class of 20 to 29 is what? Well, because the class width correspond of the number of integral value, when I count what I have as a value, I got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, or 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I suggest that you use your finger and you will see that the number of integral values are 10. All right, problem number 7. So what is the problem number 7? So this problem number 7. So in a stem and leaf display. So right now we are in a stem and leaf display. So I will let you refer to your lecture note that you took about what is a stem and leaf display. But the left group of digit is called, and on the stem and leaf display, the left group of digit is called stem. And the right group of digits is called leaf. All right, problem number 9. On the problem number 9, we have a chart, we have a class, 9 to 15, and then we have, so on the left, we have the class, on the right, we have the frequency, and basically what we have to do is use the frequency distribution to determine A, the total number of observation. How many observations did I observe? So A, how many number of observations? Okay, when I look at the frequency, I can see that if I add all the frequency, I can see that the number of observation is going to be 4 plus 7 plus 1 plus 0 plus 3 plus 5, and end up to have 20. The question B for problem number 9 is the width of each class. What is the width of each class? So the width of each class is, and it is 7. Why is it 7? When I look at the class, the first class, 9 to 15, 9, 10, 11, 12, 13, 14, 15. When I count with my hand, I can see 7 integral values. 16, 17, 18, 19, 20, 21, 22, and I can do that for all of them, and I will find 7. Problem number 9, question number C. The question number C is the midpoint of the class. So what is the midpoint? So to find the midpoint of a class, we add the lower and the upper class limit divided by 2. So we have on the second class, because they're asking you to find the midpoint of the second class, we have 16 plus 22 divided by 2. That gives me a 38 divided by 2, and so the midpoint is going to be 19. Question D, we are dealing now with the model class. Okay, so we are dealing now with the model class, and the model class is going to be 16, 22. Because the definition of the model class is the class with the greatest frequency, when I look at my problem, I can see that the class 16 to 22 has a frequency of 7, and that's the highest greatest frequency. So that means 1622 is the model class. Finally, question E. The class limit of the next class is an additional class where to be added. The class limit of a next class is an additional class to where added. So if in right now the last was 4450, basically what we are looking for is going to be 51, 57. Why? Because we have a total number of observations, the width of each class has to be 7, and if the previous class stopped at 50, the following class will be 51, and then I need to count 7, so 51, 52, 53, 54, 55, 56, and 57. All right, now let's do problem number, which problem do we have to do? 15. So problem number 15. All right, so in this problem number 15, use the data given in the table 12.1, page 736 and 737 to construct a frequency distribution with a first class in thousands, and we are dealing with a class of 138 to 587. All right, so in this chapter, on this question, in question number 15, we need to make a reference to table 12.1, page 737. And I can see that I have a set of information, Detroit newspaper, and then the circulation in thousands, going from 210 for the Detroit Free Press to Press Enterprise, which is 138. And we have a class 138 to 587. So when I look at that, I can see that there is 46 newspaper. Then obviously I'm going to have 588, and I need to have the same number that there is between 138 and 587, but this time starting by 588, and it's going to be 1037. And then I will have 1038, and that will go to 1000. If I had, I'm going to have 1487. And then 1488, and that will go to 1937, and then 1938, and that will go to 2387. When I look at the number of paper between in circulation for the class 588 and 1037, I can see 1. There is 0 for the other one. There is 2, and there is 1 for 1938 to 2387. All right, so that is all about looking at the chapter 12 and counting how many newspapers you have in between 138 and 587 and all the way up to 2,387. I think we have problem number 27 and then 32. So problem number 27. Problem number 27. So in this problem number 27, we have the following table. So you have a table showing the sale of 15 top-selling vehicles in the United States in thousands of vehicles, and you need to construct a frequency distribution with a first class of 18 to 24. So we have a first class 18 to 24. So what does that mean? That means that I have 18, 19, 20, 21, 22, 23, 24. There is a width of 6. So obviously I will end up with this problem number 27 to have the second class will be 25 to 31. Then I will do 32 to 38. Then I will do 39 to 45. Then I could do 46 to 52. Then I will do 53 to 59. And finally, I will look at 60 to 66. And when I count the number of automobiles, number of cars, for the first class it is 7, for the second it is 4. Then I have 1, 1, and 1 for the third, the three following. Then I will have 0 for 53 to 59, but 1 for 60 to 66. The second question of this problem number 27, it's about construct an histogram and then construct a frequency polygon. So if I want to construct a histogram, what am I going to have? So first of all, I'm going to have 2 axes, and on the vertical axis will be the number of cars. So right there will be the number of cars, and on the horizontal axis will be the number of sales by thousands. Okay, by thousands. So I have how am I going to write that? All right, give me just a second. All right, so in this problem number 27, we need to construct an histogram. For that, I'm going to represent the different classes, and I know that there is different number of cars. So vertically, I will have the different number of car, and on the horizontal axis, I will have the sale of thousands. And then I can see that between 18 to 25, basically, because we're starting from after 25, which is 27. So between 18 to 25, I got 7. And so I'm going to have right here something corresponding. Let me represent that with another color. So right here, we're having 7. So that corresponds to 7. Then I can have the other one right there, which is going to correspond to 4. Okay? All right. Then I could have the one who are going to be equal to 1. Oops. To 1. And they are right here. 1, 1, and 1. When I had just previously a 4, and I add in purple a 7. So the last one is going to be this one, and it's also going to be 1. Now, if I want to graph the frequency polygon, I need to look at the